Hello everyone. So in this video, we will solve this set of problems. At the beginning of every problem, you will see the full question with a 3-second timer like this. I urge you, I beg you to pause the video when you see the timer and try to solve the problem yourself first. This will really help you become more independent and better at problem solving. There is another important reason. If you solve the problem independently, it will really expand your thinking. And sometimes you will witness that your solution is better, smarter than mine. And those will be proud moments indeed. Alright, let's get started then. Remember to pause the video when you see the timer. Which of the following symbols for signs of the zodiac has an axis of symmetry? Okay, axis of symmetry. What is an axis of symmetry? Basically, let me draw a rectangle. Rectangle has two axes of symmetry. One is this, the other one is this. So basically, axis of symmetry is if you try to fold the shape along that line, the two sides will exactly overlap. Okay, so I have actually make a drawing. So this is a rectangle. So this has two lines of symmetry. One is like this, one is like this. So if I try to fold it along this, it will exactly overlap. Similarly, if I try to fold along this line, it will exactly overlap. On the other hand, if I try to fold it along the diagonal, as you can see, it will not exactly overlap. It is not going to exactly overlap. So the diagonal is not an axis of symmetry for a rectangle in general. However, if I take a square, it will have this as a line of symmetry, this as a line of symmetry, even the diagonals will be line of symmetry. So it will have 1, 2, 3, 4 lines of symmetry. Something like this, right? For a square, I can fold it along this line, it will exactly overlap. I can fold it along this line, it will exactly overlap. I can also fold it along the diagonals and it will exactly overlap, right? Similarly, the other diagonal too. So for each of these shapes, we need to find a line along which if we fold it, it will exactly overlap. So we can see that for the first shape, if I fold it along this line, they will exactly overlap. Meaning, if I fold along this line, this is going to overlap with this is going to overlap with this, and this is going to overlap with this. But for the other shapes, I cannot find such a line. Then A is the correct choice. The figure shows 3 concentric circles with 4 lines passing through their common center. What percentage of the figure is shaded? What percentage of the figure? 3 concentric circles. Right? Okay, so we have 1, 2, and 3 concentric circles, and there are 4 lines passing through their centers. If we know the angle, right, we can calculate the area. But we do not know the angle or the radius, right? But one thing we know that is if I take 2 lines, one like this and one like this, so they are both passing through the center, then this area is going to be the same as this area, right? So what I can do is I can get rid of this part of the area and bring it here instead. Similarly, if you look at this area here, this is going to be the same as this, right? Okay, I will do the same thing for here. This small area, I can get rid of that. I can have this instead. Once we do that, as you can see, this half of the big circle is completely shaded, right? And half is basically 50%, right? then the correct choice is E. So for problems like this, where it seems that we don't know these individual areas, try to move those areas around and see if you can make a complete shape that you know the area. That makes the problem much easier. What is the value of this expression here? See, this line is all the way, which means this is like in a parenthesis, right? So let me write it down. So 20, this is times 21. So this dot is times 2 plus 0 plus 2 plus 1. And this is like in a parenthesis, right? That is understood. So this is 20 times 21. I'll evaluate the parenthesis first. So 2 plus 0 is 2, plus 2 is 4, plus 1 is 5. So this is going to be 5, right? Now, I can first divide 20 with 5. So this will be 4, right? So this is a 4. 4 times 21 is 84, right? Then D is the correct choice. How many 4-digit numbers have the property that their digits from left to right are consecutive and in ascending order? Alright, so let me write down the different possible 1-digit numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? That's it. These are the different possible 1-digit number. So what is the smallest 4-digit number? It's going to be 1000. And what is the biggest 4-digit numbers? It's going to be 9999. So how many numbers are between this that satisfy this condition? Okay, consecutive and in ascending order. So let me start with the lowest one, and they have to be consecutive and ascending. So 1, 2, 3, 4, like here. 1, 2, 3, 4. I cannot start from 0 because then it will be a 3-digit number, right? So 1, 2, 3, 4 is possible. Okay. Similarly, 2, 3, 4, 5. So that is 2, 3, 4, 5, right? Let me do it here. It's easier. Then you can see the 3, 4, 5, 6. And then I can start from 4, 5, 6, 7. 5, 6, 7, 8. And then I can start from 6, 7, 8, 9. So I have 1, 2, 3, 4, 5, 6. 6 possible numbers that satisfy this condition. Then B is the correct choice. How many 4-digit numbers that have the property that their digits from left to right are consecutive and in ascending order? Ascending means increasing, right? So let me write down the different possible 1-digit numbers. There's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Alright, so these are different possible 1-digit numbers. Okay, so what is the smallest 4-digit number? It's going to be 1000. And what is the biggest possible 4-digit number? It's going to be 9999. Alright, so let me see how many 4-digit numbers I can make so that from left to right they are consecutive and in ascending order. So what is the smallest one I can make? I cannot start with 0, right? Because then it is going to be a 3-digit number, right? So I can start with 1. 1, 2, 3, 4. So 1, 2, 3, 4. This is going to be the smallest 4-digit number. They are consecutive, meaning they increase by 1. 1, 2, 3, 4. And they're ascending, meaning they increase, right? Okay. What is the next one? Next one I can start with 2. Then 2, 3, 4, 5. 2, 3, 4, 5. Let me do it here. It's much easier. Then 3, 4, 5, 6. 4-digit number. 4, 5, 6, 7. And then 5, 6, 7, 8. Then 6, 7, 8, 9. Can I start with 7? No, I cannot start with 7 because I have only 3 digits remaining, right? So how many I have? 1, 2, 3, 4, 5, and 6. So there are 6 possible numbers that satisfy this condition. Then B is the correct choice. when the 5 pieces, these, are fitted together correctly, the result is a rectangle with a calculation written on it. What is the answer to this calculation? Alright, so first let me try to make this rectangle. 1, 2. Okay, so this is a rectangle with room for those 5 pieces. One thing to know is whatever piece goes here must have the left edge flat, right? And if we look through here, this 2 is the only one that has the left edge flat, so that 2 must go there, and this 2 has a pointy thingy here, right? Okay, so this 2 is taken into account. Similarly, whatever piece goes here must have the right edge flat, right? And that is this 2 then, right? This is the only one which has the right edge flat, right? So this 2 must go there, and that 2 has a hole, right? Okay, so this 2 also is taken into account. All right, so now let's try to find room for these remaining 3 pieces. So what goes here? So it must have a hole, right? So 0 has a pointy thingy, it cannot fit there. 1 has a pointy thingy, it cannot fit there. So this is the negative sign. So the negative must go there, and the negative has a hole on the other side too, right? The negative is also taken into account. Next, here. So we have a hole here. So we need a pointy thing. Either 0 can go there or 1 can go there. So let me first try to put 0. 0 has a pointy thingy, okay? Or 1 can also fit there, right? 1. But 1 has a pointy thingy and then a hole on the other side, all right? So if I put 0 here, 1 should go here, right? So let me try to fit 1 here. 1 has a pointy thingy here. Oops. As you can see, this is not going to match, right? So this combination is not possible, right? The only other way is if I put 0 here, 0 has a pointy thingy here, as you can see, and the pointy thingy here. So this is going to match exactly here, and this is also going to match. So the correct order is 1 and 0. Now the calculation becomes 2 minus 102. 102. So 2 minus 102 is negative 100. Right? That is the correct choice. Each of the 5 vases shown has the same height, and each has a volume of 1 liter. So each has the same height and same volume. Half a liter of water is poured into each vase. In which vase would the level of the water be the highest? Okay. All right. So let me call this total height h, and let me draw a line at half. Okay. So this line h by 2. So each has a volume of 1 liter. So if I pour half a liter, let me first take a look at the easier shapes. This one, B, right? If I pour half a liter, as you can see, the bottom half has the same volume as the top half. So the half liter will be exactly on this mark, the half mark, right? Similarly, this shape, as you can see, the top half and the bottom half have the same volume. So half a liter would be just the bottom half, right? Similarly, this one is also symmetric about the half line. So if I pour half a liter, the water level will be right there. How about this one? As you can see, the bottom half, the bottom h by 2, has less volume than the top h by 2, right? Now, if I pour half a liter, since this is less than half, the water level will be somewhere here, right? The water level is going to be, so this height is going to be greater than h over 2, right? Now for this case, as you can see, the bottom half, h by 2, right, has more volume than the top, right? So if I pour half a liter, the water level will be less than h by 2, right? So this height is going to be less than h by 2. So we want the vase where the level of water would be the highest, right? Then A would be the correct choice, right? A student correctly added two two-digit numbers on the left of the board and got the answer 137. Alright, so that is this. What answer will he get if he adds the two four-digit numbers on the right of the board? Okay, so what will be the value of this? We can solve this problem using the place value, but that will be a little bit more difficult. So let me first give the easier approach. So we know that A, B, C and D, they give us 137. Alright, now let me write down this one. A, D, C, B, and then C, B, A, D, and I want to add those. Alright, now this is what is given to us. So if you look carefully, let's split this into two parts. So this is one part, and then this is another part. Okay, so here we are given A, B and C, D, but the B and D, they are swapped, right? B and D, they are swapped. But even if B and D are swapped, we will still get the same result. For example, if I have the number 37 and 12, right? If I add it, or if I swap 2 and 7, that is 32 and then 17, so I'm swapping 2 and 7, they will be the same. So this will be 9, 49, this will be 9, they will be the same, right? So even if I swap B and D, I will get the same result. Okay, so in this case, CBAD is same as ABCD, the sum, right? So this will be 137, this will be 137, alright? What about this? This is the same thing, AD and CB, right? But if I sum it up, this will be 137 too, but I have to start from here, right? Right? Because this is at the 100th place. Remember, I'm adding at the 100th place. So I have to start from the 100th place. So if I sum it up, I'll get 7, 3, 8, 3, 1. So 138, 37, 138, 37. B is the correct choice. We can also solve this problem using the place value. So let me show you that now. Alright, we are given AB plus CD is 137. So let me write it down in terms of the values, right? So AB in terms of the value, so this is at the unit place, this is at the tens place, right? So the value of that is going to be 10A because it is at tens place plus B, right? Similarly, CD is going to be 10C because C is at the tens place and D is at the unit place, so it's just D. Okay, so we are given that if I sum the values, if I add it up, this is going to be 10A plus B plus 10C plus D, right? And that value is given 137. 137. Okay. Now let me try to express these digits in terms of the place value. ADCB. So ADCB. Okay. So this is in terms of the place value, it is going to be A times what? It is at the thousands place, right? So it's going to be 1000A. D is at the hundreds place, so 100 D. C is at the 10 place, so 10C plus B is at the unit place. Similarly, CBAD, C at the 1000 place, it is 1000 C plus B is at the 100 place, 100B plus 10A, 10A, and then plus D. So if I add these two together, if I add these two together, these two, I am going to get, let me collect the like terms together. So this is 1000A and this is 10A. So that is going to be 1010A plus B. I have this and here. So 101B plus, how many C's are there? So 1010. So that is 1010C plus, okay, the only thing that is remaining is D, that is 101D. Alright, now I can see that, I can take out the factor of 101 from all the terms, right? So if I factorize it, let me write it here. This 101 times, this is 10A plus B plus 10C plus D, right? Okay, all that I have done here is taken out the factor 101, right? And once I do that, this part is exactly same as this part, right? Now, so basically, so let me continue here. So this is equal to 101 times 10A plus B plus 10C plus D. 10A plus B plus 10C plus D is 137. 137, right? Now, if I try to do 137 times 101, so this is going to be 137, then 0, 0, 0, and then 137. This will add up to 7, 3, 8, 3, 1. Right? 13837. 13837. We get the same answer. A cube 3 by 3 by 3 is made from 1 by 1 white, gray, and black cubes. White, gray, and black cubes, as shown in the first diagram. Alright, so this is the one. The other two diagrams show the white part and the black parts of the cube. Alright, so this is the white and this is the black. Okay, which of the following diagrams shows the gray part? Alright, which one is the gray part? 3D problems like this can be sometimes difficult to visualize. So what I try to do is try to find some reference structures and try to match. In this case, we want to find the gray part. So let's take a look at the gray here. I can see that, I have some reference here. The two side by side goes down and like this, right? So if I try to match that, here I have only one on the second layer. So this is not going to match, right? Here I have 3, that is also not going to match. Here I have 2, okay, that's fine. And then 2 and then down, 2 and then down, and then there should be another one here, right? So there is nothing there. That will not match. Here there is 2 side by side on the second layer and down, and so that matches this structure. Here also 2 side by side, 1 down and 1 to the side. So these two are possible choices, just taking this part as the reference. Now there are 2 more grays here, so let's try to see which one matches this. So I have one at the this corner here and one at that corner. So I can see one here, but I see 2 here, but this is a black one, right? So this is a black one, so this should be a black one, right? So this is not going to work. Then seems like this and this is matching with this, and that is the only choice remaining. Then E is the correct choice. A bike clock has 4 wheels numbered with digits 0 to 9 in order. Each of the 4 wheels is rotated by 180 degree from the code shown in the first diagram to get the correct code. What is the correct code for the bike clock? So there is a code shown here that needs to be rotated 180 degree to get the correct code. And what is that correct code? Alright, so let me make the number dial. That will make it much easier. So I need 0 to 9, I need 10 spots. 1, 2, I need 4 here. 1, 2, 3, 4, and 4 here. 1, 2, 3, 4. Let me number them. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Alright, so 0 is opposite of 5, right? 1, 6, 2, 7, 3, 8, and 4, 9. So they are 180 degree apart. Alright, so if we start with 6, and go 180 degree, as you can see, it doesn't matter whether we go clockwise or anti-clockwise, we end up at the same number. So from 6 on the opposite side we find 1, so this will be 1 if we rotate it 180 degree. Similarly 3, if we start from 3, go 180 degree, we end up at 8. And then we start at 4, go 180 degree, we end up at 9. Start at 8, go 180 degree, we end up at 3, right? 1893, 1893, this is the only one that matches, then B is the correct choice. Byron is 5 cm taller than Aaron, but 10 cm shorter than Caron. Alright, some height comparison is given. And the question is, which of the following statements is true? Okay. As you notice, their names conveniently start with the alphabets A, B, C, D, E. So I'll make use of that. So let me draw a reference line here. Let me draw the height of Aaron. Call it A. I don't know this height, but I'm going to use that height as a reference and draw the other heights. So Byron is 5 cm taller than Aaron. Okay. So whatever Aaron is 5 cm taller is Byron. So this is B and this is 5 cm. Okay, but 10 cm shorter than Caron. That is, Byron is 10 cm shorter. That means Caron is 10 cm taller, right? So 5, another 5. So this is 10. So this is C, right? Okay, Darren is 10 cm taller than Caron. Okay, Darren is 10 cm. So 10 from this, right? 10 from this is D, right? But 5 cm shorter than Erin. That means Erin is even taller. So 5 more from here. That is Erin, right? This is 5. Okay. Now, which of the following statements is true? Aaron and Erin are of equal height. This is Aaron, this is Erin. They are definitely not of equal height. So that is not correct choice. Aaron is 10 cm taller than Erin. Aaron is 10 cm. No, Aaron is actually shorter than Erin, right? Aaron is 10 cm shorter than Erin. Aaron is 10 cm shorter. No. So this height difference is 5 plus 10 is 15 plus 10 is 25 plus 5, 30, right? It's not 10 cm. Aaron is 30 cm taller than Erin. Aaron is 30 cm taller. No, Aaron is actually shorter. Aaron is 30 cm shorter than Erin. Yes. This height difference is 5 plus 10 is 15 plus 10 is 25 plus 30 plus 5 is 30. That is 30 cm, right? So Aaron is 30 cm shorter than Erin, and E is the correct choice. A rectangular chocolate bar is made of equal squares. Neil breaks up two complete strips of squares and eats 12 squares he obtained. So in 2 strips has 12. So 1 strip must have 6. Later Jack breaks up 1 complete strip of squares from the same bar and eats 9 squares he obtained. How many squares of chocolate are left in the bar? Alright, first Neil breaks up 2 complete strips and that has 12. So one strip must have 6. So let me draw that 6. 1, 2, 3, 4, 5, 6. And he breaks 2 strips. So this is the other strip. So this has 12 squares, right? And then Jack breaks up one complete strip of squares from the same bar, and it's 9 square. So now he is 9. So he cannot be breaking from a strip like this, right? Because this way it has only 6. So he must be breaking this way. So 1, 2, 3, 4, 5, 6, 7, 8. So these are the 9 square, right? Let me number it. 1, 2, 3, 4, 5, 6, 7, 8, and 9. This way 1, 2, 3, 4, 5, and 6. All right. So how many squares of chocolates are left? So this is the square. So the square must be like this, right? And this is left. This is left. So this is 9 times one column is already gone, so times 5, because this is only 5, right? Only 5 is left, right? So this is 45. D is the correct choice. All right. I was thinking a little bit more about this problem, and one question you may have is, Neil needs 12 squares from 2 strips, but it doesn't say he has to break the 2 strips at once, right? He can break one strip like this, 1, 2, 3, 4, 5, 6. So this strip has 6, 1, 2, 3, 4, 5, 6, and then he can break another strip like this, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. But the problem with this is that later Jack needs 9, but this way there are only 5 remaining, right? 1 is already taken, so 1, 2, 3, 4, 5 is remaining, and this way we have only 6. So Jack cannot break a strip of 9 later, right? But then you can ask, Neil needs 12 squares, right? But it doesn't say he breaks 2 equal strips. He says 2 complete strips, right? So you can say Neil can take 3 like this and 9 like this. 7, 8, 9. 7, 8, 9. So Neil can take 3 like this and then 9 like this. So they together, 9 plus 3 is 12, right? So I'm breaking it 3 plus 9, not 4 plus 8 or 2 plus 10, because I know that later I need a strip of 9, right? And again later Jack can take this strip of 9, right? So this is a valid configuration. So now in this case, what will be remaining is this strip, right? So this is what will be remaining, and this has 9, right? So 9 is a valid solution, but 9 is not one of the choices that are given to us. So for this problem, 45 is still the correct answer. A jar 1/5 filled with water is 560 gram. The same jar 4/5 filled with water, 740 gram. What is the weight of the empty jar? All right. So let me draw the jar. So this is the jar, and this is divided into 5. 1, 2, 3, 4. All right. So this is my jar. 1, 2, 3, 4, 5, and this is 1/5 filled. So this is 560 gram, right? Now the same jar 4/5 filled. I'll draw it again. It's the same jar. 1, 2, 3, 4. Now this is 4/5 filled, right? So this is 1, 2, 3, 4, 4/5 filled. This is 740 gram. So this is 4/5 filled. If I take away the jar and 1/4, then only this will be remaining. Only this water will be remaining, right? So if I take away the jar and 1/5, then only 1 to 3/5. 3/5 water. This is going to be 740 minus 560. Right? So what I'm doing is, so here the jar is 4/5 filled, here 1/5 filled. So I'm taking away the jar and 1/5 of the water. So I'm taking away the jar and 1/5. So what I'm remaining is 3/5 of water, right? And that is going to be, so this is going to be 180, right? So 3/5 of water is 180. And I need to find the weight of empty jar. So in this case, I have 1/5 water, right? So let me find out the weight of 1/5 of water and then I subtract that from here. So 1/5 water is going to be, 3/5 is 180, 1/5 is 180 by 3, right? This is going to be 60. So the 1/5 water is 60 grams. That means this is 60 gram, right? Then the jug will be, 560 minus 60. I take away the weight of the water is 500 gram, right? So the empty jar is 500 gram. We can also solve this problem using algebra. Let me show how. All right. A jar and 1/5 water is 500. Let me call J for jar and 1/5 water, W for full water, and 1/5 of that is 560. The same jar 4/5 filled. Jar 4/5 filled. So jar plus 4/5 water is 740. Okay, so this is equation 1, this is equation 2. If I subtract 1 from 2, so this again, jar plus 4/5 W is equal to 740, and then I want to subtract J plus 1/5 W is equal to 560. I want to subtract this whole equation. And where do I want to subtract? So that, I'll take out the jar from there, right? So this J will cancel out with this. So 4/5 minus 1/5 is 3/5. W is 740 minus 560 is 180, right? Okay. So from here, water is going to be, I multiply both sides by 5 and divide both sides by 3. That is 180 times 5 by 3. So that is the weight of water. I need to find the weight of jar, right? So I can use equation 1. Jar equal to 560 minus 1/5 W, 1/5 W. This is 560 minus 1. And then W is 180 times 5 by 3, right? So this 5 cancels, this goes 60. So this is 560 minus 60 is 500, right? Then jar is 500 gram. We get the same answer. The area of large square is 16 centimeter square and the area of each small square is 1 centimeter square. What is the total area of the central flower in centimeter square, right? Total area of the central flower. That is the yellow part, right? So the big square is 16 centimeter square, so the each side has to be 4, right? 4 times 4 is 16, so this has to be 4, okay? Now the small square is 1 centimeter square, that means each side has to be 1 because 1 times 1 is 1. So that is the area, right? Now we can try to find the, divide the each yellow shape as 2 triangles, right? But oftentimes for problem like this, you will see that it's easier to arrive at this shape by finding a larger shape and then subtracting other shapes that we know, right? So let's try to do that. So in this case, I already know the area of the bigger square and the smaller square. All I need to do is, if I can find out the area of this triangle, I'm set, right? So what is going to be the base? We know the whole thing is 4. This is 1. This is 1. So the base of the triangle has to be 2, right? What is the height? This height is going to be, we know this is a square and this is the midpoint. If the side is 4, half of that is going to be 2, right? So area of one of the triangle is half times base is 2 times height is also 2. So this is the area of one of the triangle, right? So this is basically 2. So area of one white triangle. Okay, and how do I find the area of the yellow region? I take the area of the whole thing, that is 4, minus, first subtract away 4 of these, 4 times the small squares are 1 unit each, minus, I also have to take out 4 of these triangles. 4 times each triangle we computed as 2, right? And then what is remaining is the yellow region, right? So this is then going to be, so this is, okay, I made a mistake. The area of the bigger region is 16, not 4, right? It's 16. The side is 4, but the area is 16, right? The area of the small, and there are 4 small and each is 1, so this is correct. There are 4 white triangles and each is 2, so this is correct too. So this is 4, this is 8. 8 plus 4 is 12. If we take away 12 from 16, I end up with 4. Then the area of the flower is 4 centimeters square. Costa is building a new fence in his garden. He uses 25 planks of wood, each of which are 30 centimeters long. He arranges these planks so that there is the same slight overlap between any 2 adjacent planks. Okay, so the overlap is same between any adjacent planks. The total length of Costa's new fence is 6.9 meters. What is the length in centimeters of the overlap between any pair of adjacent planks? So we need to find the length of overlap in centimeters. All right, so for problems like this, you see the planks that are in between, they have 2 overlaps. The planks that are at the end, they have only 1 overlap. So it can get a little bit confusing to think. So for a problem like this, you can always come up with a convention and stick with it. So in this case, this is what I mean. So the length from here to here is given to us, that is 6.9 meter. How can I get that length? I start from the first plank and it where it ends. Okay, so from there I go to the next and it where it ends. Go to the next and it where it ends. So on and so forth. So I end here and here. Okay. Now if I can add up these lengths, I should get 6.9 meter. So what is this length? This is 30, right? So let me say this is plank 1, 2, 3, all the way to I have plank 24 and 25. Okay. So for plank 1, I'm taking the whole length. For plank 2, what is this distance? Remember, there is some overlap that I have taken it away. Let me call that overlap x. right? Then this is going to be 30 minus x, right? So I'm going until the end, but in the beginning, I have taken away the overlap. So for plank 2, I am counting 30 minus x. How about plank 3? So this is plank 1, this is plank 2, this is plank 3. Again, I'm taking away this overlap, and what is remaining? This is 30 minus x, because the overlap amount is the same, right? So plank 3, I'm taking 30 minus x, okay? Similarly, here I have taken away this overlap, so this is going to be 30 minus x, right? So that will be plank 24, 25. So this will be 30 minus x. Same for plank 25, 30 minus x, because that overlap is gone, right? All right. So, and this all together, if I add up all this, right, I should get 6.9 meter, but this is in centimeter, so I'll convert the meters to centimeter. 6.9 meter, 1 meter is 100 centimeter, so 100 times 6.9 is 690, right? 690. So everything is in centimeter now, so I don't need to worry about the units. Now let's see how many of these are there. This is 1, 2. How many of these are there? I have 130 plus I have 24 more left, right? I have 24. So these are 24. These are total 24 because I have already accounted for 1. So there is 24 times 30 minus x. This must be 690. All right. So this is 30 plus 24 times 30 is 720 minus 24x is equal to 690. Okay, I have just opened the bracket here. Now this is so let me start writing there. This is 720 plus 30 is 750 minus 24x is equal to 690, right? So I take the 24x to that side, I bring the 690 to this side. So 750 minus 690 is 60 is equal to 24x, right? Then x is going to be 60 over 24. So this is if I divide both numerator and denominator by 2, this is 30, this is 12. Again, I will divide by 3 or 6. So this is 5 over 2, which is 2.5, right? So the overlap, then I have assumed x to be the overlap. So overlap is 2.5, then B is the correct choice. There is one more way to think about this problem. Let's say if there was no overlap, right? So if you lay down all the 25 planks next to each other, that would be 25 times 30. That is how much long it will be, right? But there is some overlap, right? So I have to subtract away that length. And if I have 2 planks only, there is only 1 overlap. If I have 3 planks, there will be 2 overlaps, right? Similarly, if there are 25 planks, there will be 1 less overlap, that is 24 overlaps, right? And if each overlap is x, that will be 24x. So 24x. Okay. So again, so 25 times 30 is the length if there was no overlap at all. And if I laid each plank next to each other, right? So that would be the length 25 times 30, right? And then I'm subtracting the overlap. There are 24 overlaps and each overlap is of amount x. Here sometimes students make mistake. Overlap is x, so they subtract 2x. We cannot subtract 2x, right? So if there is a plank here, and there is another plank here, if the overlap is x, right, I have to subtract only one x, right? Because if I subtract both the x, then this plank comes here and stops here, and this plank starts from here, and there will be a gap. So we have to subtract only one x, right, for each overlap. And there are 24 such overlaps. So that is 24x, and that length, after I subtract away the overlap, that should give me 6.9 meter or 690 centimeter, right? So everything is in centimeter now. And 25 times 30 is going to be 750 minus 24x is equal to 690. Now, if you look carefully, this is exactly same as this equation, right? These two equations are exactly the same, right? So we will get the same answer, but I just wanted to highlight another way of thinking about it. 5 identical right angle triangles can be arranged so that their larger acute angles touch to form the star shown in the diagram. This is the diagram. It is also possible to form a different star by arranging more of these triangles so that their smaller acute angles touch. How many triangles are needed to form the second star? All right, so we have 5 identical right angle triangles, and they form this star by touching their larger acute angles. So let's take a look at one of the triangle. So this is the right angle. This is the larger acute angle of this triangle. This will be the smaller one, as you can see. Similarly, this is the larger acute angle of this triangle. They touch. This is of this one, this is of this one, and this is of this one. So the 5 larger acute angles, they touch to form this star. The key thing to notice here though is these 5 larger acute angles, right? They touch to form the full circle or 360 degree. So if I call one of the larger acute angles as x, so 5 of those, 5x is 360 degree. Then 1x is going to be 360 by 5, and this is going to be 72 degree, right? So large acute angle is 72 degree. Now I can find the value of the smaller acute angle, right? Because for a triangle, all the 3 angles add up to 180 degree. And once I find the smaller acute angle, I can calculate how many of those I need to form the full circle. So that is the thought process. All right. So let me take one triangle. For this triangle, the right angle is 90 degree plus the larger acute angle is x plus, let me call the smaller acute angle as y plus y, and all the 3 angles of the triangle, they must add up to 180 degree. So let me take away 90 from 180 and 90 remains. X, the larger acute angle, I have already computed that to be 72. Then y is 90 minus 72. I'm taking the 72 to the other side. Then y is 18. Okay, so this is the smaller acute angle. So how many of those I need to form the full circle? So full circle is 360 degree divided by y. So that is how many of the triangles I need to complete the full circle. So that is 360 by 18, because I have already calculated y to be 18, and this is going to be 20. This is going to be 20. All right. Then I need 20 of the triangles to form the star the second way, where their smaller acute angles are touching. Then the correct choice is D. 5 squares are positioned as shown. The small square indicated has area 1. This square has area 1. What is the value of h? If this square has area of 1, then the sides are of length 1. As you can see, the small square is related to the next big square through this small distance here. So let me call it x. If this is x, what will be this length? That will be 1 plus x, right? Because the small square has side 1 plus this x, so there is 1 plus x, and since this is a square, this side is same as this side. All right, then what is the length of this side? So this is a square too, so 1 plus x plus 1, that is 2 plus x. Similarly, what will be this length? This length is same as this length, but this is 2 plus x plus 1, so there is 3 plus x, so this will be 3 plus x. All right, now what will be this length? This is a square too, so this is same as this 3 plus x plus 1, so there is 4 plus x, right? But this length is also same as this length, right? So that is h plus x. This is h, and we have assumed this small distance to be x. That is same as 4 plus x. We cancel out x both side, then h is equal to 4. C is the correct choice. There are 20 questions in a quiz. Each correct answer scores 7 points. So 7 points for each correct answers. Each wrong answer scores -4 points, and each question left blank scores 0 points. Eric took the quiz and scores 100 points, so 100 points total. How many questions did he leave blank? All right. We can solve this problem using algebra. So let me try that. Let me call C for number of correct answers, and then W for number of wrong answers, and B for number of blank answers. So we know that C plus W plus B must be 20 because there are total 20 questions. So the number he got correct, the number of questions he got correct, plus number of questions he got wrong, plus number of questions he left blank, they must add up to 20. So this is equation 1. What is the other piece of information we have here? He scored a total of 100 points. If he got C questions correct, for each he gets 7 points. For C questions, he will get 7 C points. All right. All right. For wrong, for each wrong answer, he gets -4 points. For W wrong, he will get -4 times W points. Right. All right. So for each blank, he scores 0 points. For B blank, he will score 0 times B points, and this is 0 anyway, so we can disregard this. And the total points must add up to 100, right? So this is equation 2. All right. Now what I can do is try to substitute C from here to here, from equation 1 to equation 2. So 7 times, what is C? C is 20, and I'll take W and B to the other side. So 20 minus W minus B. So this whole thing is nothing but C. And then so this plus and minus is going to be minus 4W. This must be 100, right? So let me try to do some simplification. First, I'll open the bracket. So this is 140 minus 7W minus 7B. This minus 4W should be 100, or I'll collect the like terms, right? So this is 140 minus 11W, 7 plus 4 is 11, minus 7B is equal to 100. What I will do is take the terms that contains the unknown to the right hand side and bring 100 to this side. So this will be 140 minus 100 is 40, right? I'm bringing 100 to this side. So 140 minus 100 is 40, and 11W and 7B go to that side. 11W plus 7B. All right. Okay, I want number of questions he left blank. Okay, so let me just rewrite that here. What I'm going to do, I'm just copying it, but I'll switch the side. So 11W plus 7B is equal to 40, right? This is exactly same as this equation, right? Okay, I need number of blanks, so let me figure out how many blank from this equation. So B is equal to this 40 minus, I take 11W to that side, 11W divided by 7, right? So all that I have done is express B in terms of other quantities, right? All right, so this is the equation we have. We have one equation but two unknowns, right? So how do we solve that? We have one more piece of information that we can use. It is not explicitly stated here, but it is kind of given. Note that the number of questions he left blank and number of questions he got wrong, B and W, they have to be positive integers. It can be zero also, zero or positive integers. They cannot be negative, they cannot be fraction, right? All right, so let's try to use that information. Let's assume I'll make a small table here, W for wrong number of wrong answers and B for number of questions he left blank. Let's say he got 0 questions wrong. Then if this is 0, W is 0, this is 40 by 7, right? So this many questions he must have left blank, but 40 is not divisible by 7, right? So number of questions left blank cannot be a fraction, so this cannot be a correct choice. How about if he got 1 question wrong? Then W, if the W is 1, 11 times 1 is 11, so 40 minus 11 is 29, right? So 29 by 7, again this is 29 is not divisible by 7, so that cannot be a correct solution. How about he got 2 questions wrong? If he got 2 questions wrong, 11 times 2 is 22, 40 minus 22 is 18, 18 by 7, again 18 is not divisible by 7, so this cannot be it. How if you got 3 questions wrong, right? 3 questions wrong. If you got 3 questions wrong, 11 times 3 is 33, 40 minus 33 is 7. Okay, 7 by 7 is 1. All right, so this seems like a valid solution. Let's try one more. What if W is 4? If W is 4, 11 times 4 is 44. So 40 minus 44 is negative 4. So negative 4 by 7, right? So we are going in the negative direction right now because the number of questions he left blank cannot be a negative number, right? So again, the other options for W are not going to work. So seems like this is the only correct solution for this, right? That means he got 3 questions wrong and 1 blank. Then B is the correct choice, right? It is asking how many questions he left blank, and he left 1 question blank, so B is the correct choice. All right, I actually wanted to make a point here. In algebra problems, you typically need, if you have n unknowns, you need n pieces of independent or different information to be able to solve for those n unknowns. So in this case, I have 3 unknowns, C, W, and B, and I needed 3 pieces of independent or different information, right? 2 are given to us. One is that they all add up to 20, and the other one is the total score is 100. So out of those 2 informations, I made 2 equations. But then at the end, I was stuck with this. I needed one more piece of information. And sometimes that will not be given to you explicitly. You have to infer, you have to come up with that information, right? And in this case, we had to infer that W and B, they cannot be negative or they cannot be fractions. and we needed that information to be able to solve. So remember that if there are n unknowns to solve for, you need n pieces of independent or different information. And sometimes not all the information will be given to you explicitly. You have to infer some of those information. All right. We can also solve this problem without using algebra. So let me quickly show you how to do that. And sometimes, depending on the question, sometimes the non-algebra method can be a little bit quicker if you know or if you have practiced how to do it. Sometimes the algebra method may be a little bit easier, but you should know both. All right. So let's say he got all the 20 questions right. So for each he gets 7 points. So he would get 140 points if he got all the questions right. But he got only 100 points. That means he got some questions wrong and some questions he left blank, right? And we need to find out how many of those. So for each questions wrong, right, how many points do I have to take away from here? I have to take away the 7 extra points that I have given, assuming that he got it right. Plus, there is also negative marking, right? I have to also take away that 4 points, right? So for every questions that he got wrong, I have to take away 11 points from here, right? Not just 7, right? Think about it, right? And then for every question he left blank, I have to take away the 7 points that I had given to him, right? There is no negative marking, so nothing else is needed. All right. So for every wrong answer, I have to take away 11 points. Every blank, I have to take away 7 points. And somehow I have to take a combination of 11 and 7 points to reduce 40 points from here. And one way, if you just think about different possibilities, you can see that, I have to take 3 of those 11 plus, one of those 7 points, right? So they add up to 40. So this is going to be 33. This is going to be 7. So they add up to 40, right? So he must have gotten 3 wrong and 1 blank, right? And then again we get the same answer. A rectangular strip of paper of dimensions this is folded as shown in the diagram. 2 rectangles are formed with areas P and Q, where P is equal to 2Q. What is the value of X? All right. So what is the value of this X? We are given that P is equal to 2Q. Now what is P? We know that the paper is 4 by 13. So this must be 4. So the area P is 4X. 4X is equal to 2 times Q. All right. What is Q? When we fold the paper, this is also going to be 4, right? When I fold it, the side that is opposite to this is this. So this is also 4. What is this distance? The total this plus this is 13, right? Then I have to take away this distance minus X. Then I have to take away this distance, but this is 4 minus 4, right? And that will be this. That will be this distance, which is same as this distance here, right? So this is this. So this is going to be 13 minus 4 is 9 minus X. All right. So what is the area Q then? Q is 4 base time height, right? So 4 times 9 minus X. So that is Q. So let me substitute that Q here. So 4 times 9 minus X. All right. So I cancel out 4 from both sides. That means X is equal to, I open the bracket, 18 minus 2X. I bring the 2X to this side. So 2X plus X is going to be 3X is equal to 18. Divide both sides by 3. This gives me X is equal to 18 by 3 is 6, right? Then C is the correct choice. There is another way we can solve this problem. If you think about it, the folded part is this triangle and the triangle identical to it that is underneath. So those are the 2 triangles that are folded on top of each other, right? So what is the area of this triangle? Let me denote this as the area of the triangle. half times base, this base. Okay, the dimension of the paper is given to be 4 by 13. So this is 4. Now when I fold it, the side that is opposite to this is this, that will also be 4, right? That means this will be 4, and since this is 4, this is also 4. So the area of the triangle is half times base, which is 4, times height, which is also 4, right? But remember, there are two triangles, one on top that you can see and one right underneath, right? So area of those two triangles, that is the part of the paper that is folded, is 2 times the area of the triangle is basically 4 times 4, right? Okay, so if I take away the folded area from the entire area, what I'll have left with is just P and Q, right? So P plus Q, that is the area that is left to it. If I take away the folded area, this will be, so the total area, so 4 times 13 minus the folded area I just found out is 4 times 4, right? So this is, if I use the distributive property, it is going to be 4 times 13 minus 4. I'm just using the distributive property here. So this is going to be just 4 times 9, right? On this side, P plus Q, but I know P is equal to 2Q. This is 2Q. So then this is 2Q plus Q is 3Q is equal to 4 times 9. I can divide both sides by 3. Then Q is going to be 4 times 3 is 12. So Q is 12. But I need to find X, and X is on this side. So let me do that. So P I know is 2Q. What is P? P is 4x, right? The area of this rectangle is 4 times x. So 4x is 2Q. Q I have already found out to be 12. So 2 times 12. I divide both sides by 4. Then x is equal to 2 times 3 is 6. And we get the same answer. A box of fruit contains twice as many apples as pears. Christy and Lily divided them up so that Christy had twice as many pieces of fruit as Lily. Which one of the following statements is always true? Okay. And these are the different statements. This is one of those problems. If you use algebra, it makes it unnecessarily complicated. So I will try to solve this using a simple example, not using algebra. Okay. The first condition is twice as many apples as pears. So if there is one pear, there has to be 2 apples, right? It's a very simple example, right? Now, Christy, the other condition is Christy had twice as many pieces of fruit as Lily. So if Lily gets one part, Christy has to get 2 parts, right? Now, let's check the conditions one at a time. Christy took at least one pear. Not necessarily, because Christy can get 2 apples and Lily can get the pear. So it is not necessarily true that Christy took at least one pear. It's not necessarily true all the time. Christy took twice as many apples as pears. Okay. Again, from this example, Christy took 0 pear but got 2 apples, right? So Christy took twice as many apples as pears. Pears was 0, apples was 2, which is, so this condition is also not necessarily always true. Christy took twice as many apples as Lily. Christy took twice as many apples as Lily, but Lily got 0 apple here. So again, this is also not always true. Christy took as many apples as Lily got pears. No, because Christy got 2 apples, Lily got only 1 pear. So this is also not necessarily true. Christy took as many pears as Lily got apples. So Christy took as many pears. So in this case, Christy got 0 pears as Lily got apples. Lily got 0 apples. So seems like this can work, but let me try to have a few more examples. Let's say Christy got an apple and a pear, so Lily must get this, right? So with this example, these are the only two choices. And in this case, Christy took as many pears. So Christy took one pear, as Lily got apples. Lily got one apple, right? So with this simple example, right, we can see that, this will be always true, right? We can also try to come up with few more examples, but we will see that, this will be always true. Then E is the correct choice. Three villages are connected by paths as shown here. From Downend to Offhill, the detour via Middleton is 1 kilometer longer than the direct path. Alright, some paths are given. The question is, how long is the shortest of the three direct paths between the villages? Alright. Okay. Unlike the last example, in this example, if you can write down the algebra equations, it makes it much easier. Now you'll be thinking, okay, how to know where to use algebra and where not? It boils down to mostly practice and experience. The more you practice this kind of questions, the more naturally it will come to you, whether to use algebra or not. Oftentimes, actually, algebra makes it easy, but sometimes, like the last example, it will make it a little bit more complicated. Non-algebra way will be easier. So again, it comes down to practice and experience. In this case, let's use algebra. And as you can see, the towns are conveniently named down, middle, and up. So that's good. So let me call this distance x, this is y, and this is z. Some variable names. Now let's take the first condition. From Downend to Offhill, the detour via Middleton is 1 kilometer longer than the direct path. So D to U, but via M, right? So that is x plus y is 1 kilometer longer than the direct path. Direct path is G, so G plus 1, right? What is the next condition? From Downend to Middleton, the detour via Offhill is 5 kilometer longer. Okay, D to M, but via U, right? Right. So that is G plus Y is 5 kilometers longer than the direct path. Direct path is X, so X plus 5. All right. From Offhill to Middleton, the detour via Downend is 7 kilometers longer, right? From U to M, but via D, that is G plus X is the direct path is Y plus 7. All right, so these are the three equations, 1, 2, and 3. All right, just by staring at these equations, right, if I can add up all the three equations, let's say equation 1 plus equation 2 plus equation 3, right? So I'm adding it up and I'll write the result here. I can see that there are two Z's, there are two Y's, and there are two X's, right? So it is 2 times X plus Y plus Z is equal to, there is 1X, 1Y, 1Z. So there is X plus Y plus Z plus 7 plus 5 is 12 plus 1 is 13, right? So this one whole X plus Y plus Z, I can take out 1 from this side. That means X plus Y plus Z is 13. This is my fourth equation. All right. Now next, I'll try to use these equations one at a time with 4 and see where I get. X plus Y plus Z is equal to 13, right? That is equation 4. And X plus Y is Z plus 1. That is from equation 1, right? So this is 2Z plus 1 is equal to 13. This tells me if I subtract 1, that is going to be 12, then divide by 2, that tells me Z is equal to 6. Similarly, x plus y plus z is 13. So x plus y plus z is equal to 13. And then I use the second equation, z plus y is x plus 5. So z plus y is x plus 5, right? That is from second equation. So this is 2x plus 5 is equal to 13. This tells me if I take away 5 from 13, that is 8. So x is equal to 4. Okay, again same, x plus y plus z is equal to 13, and I use the last equation, z plus x is y plus 7. So z plus x, these two, is y plus 7, y plus 7. So this is 2y plus 7 is equal to 13. That means, so this tells me if I take away 7 from 13, that is 6, divide that by 2, 3. So y is equal to 3. So I got the three parts, that is x is 4, y is 3, and z is 6, right? And I need to find out how long is the shortest of the three direct paths. The shortest one is 3, that is, then C is the correct choice. 5 friends talk about their collected astro-pins, planets, moons, or stars. Xenia says, I have an even number of pins. Jack, all right, so different friends say different things. And the question is, below are the collections of the 5 friends. Which set of pins belong to Q11 A? Okay. So let me note down the names of the friends. They conveniently start with different letters. X, Z, S, P, and Y. Okay. So let me note that down. I'll make a small table here so that it's easy for me to, check the different options. X, Z, S, P, and Y. All right. All right. So what does X say? I have an even number of pins. So 1, 2, 3, 4. So this is possible for X. 1, 2, 3. This is not possible. 1, 2, 3, 4, 5, 6. This is also possible. 1, 2, 3, 4, 5, 6. This is also possible. 1, 2, 3, 4, 5. So this is not possible. All right. So let me also draw it like this. All right. Now, okay, X is done. Z says half of my pins are planets. Okay, half of my pins are planets. Here there are 3 planets, 1 star, so that's not possible. 1 planet, 2 stars, not possible. 3 are planets, 3 are non-planets, so this can be Z. Here there is only 1 planet, but 1, 2, 3, 4, 5 moons, so that's not possible. Here only 1 planet and 4 different, so that is also not possible. So Z, the only option is C. All right. What about Su? I don't have any moons. All right. There is no moons for Su. So yes, so this is possible. This is possible. This has moon, so this is not possible. This has moon, this is not possible. This has moon, this is not possible. All right. S is done. What does P say? Paul says, I have more moons than stars. All right. So I can see that only these 3 have moons, but here I have more moons than stars. So this is possible for Paul. I have more moons, 3 moons and 2 stars. So this is also possible for Paul. 2 moons, 2 stars. So this is not possible for Paul. Okay. Yvonne says, I have more stars than planets. I have more stars than planets. So this is not possible. More stars than planets. All right, so this is a possible choice. More stars than planets? No. More stars than planets? Yes, this is possible choice. More stars than planets? Yes, this is also possible for this. All right, so if we look at this table, right, for Z, this is the only possible choice. Then this cannot be X and this cannot be P too, right? So this is Z. Okay, we figured that out. Now P had only two choices. This cannot be it, so this must be P, right? So this must be, let me write down here, this is Z, this is P, right? So this must be P, that means this cannot be Y, this cannot be Y. All right. Okay, then what is left here? If we look at this column, the only possible choice for X is A, right? So this must be X. All right. Now, if this is X, then this cannot be S. All right. Now, if we look at this table, this is the only possible choice for S. So this must be S, right? Then that cannot be Y. Then what is remaining is Y. This has to be Y, right? Which set of pins belongs to Q11 A? Then E is the correct choice. As you can see, for questions like this, if you make a table, right, and look at one at a time, it makes it much easier. In a particular fraction, the numerator and denominator are both positive. Okay, the numerator of this fraction is increased by 40%. By what percentage should its denominator be decreased so that the new fraction is double the original fraction? All right, we can do it using algebra and non-algebra. I'll show you both. Let me first do the non-algebra, and it's very easy. All right. So this, based on the question, this should work for any fraction, right? It doesn't, it only says that it has to be positive, right? Numerator and denominator are both positive. There is no other condition. So I can assume the fraction to be 100 over 100, right? Easy. I'm choosing 100 because calculating percentage of 100 is just easier, right? Okay, so this is the original fraction. Numerator of this fraction is increased by 40%. So the numerator is 100. If I increase it by 40%, I increase it by 40. So numerator becomes 140. All right. By what percentage should its denominator be decreased? So by what percentage this should be decreased so that the new fraction is double the original fraction? So the original fraction is essentially 1, right? 100 by 100 is 1. Now, what should be this number so that this fraction is twice this? That means the denominator has to be half of this. So the denominator has to be 70, right? Then this is 2, which is 2 times the original fraction. Now, by what percentage did the denominator decrease? It decreased 30, right? From 100 to 70 is 30. So it decreased 30. So that is 30%. 30%, right? Then C is the correct choice. All right, we can also do this using algebra. So let me show that now. Let the original fraction be A over B. Okay, so A is increased by 40%. So 40% of A is basically 40 by 100. 40% is divided by 100. Of means multiplication. That is A is basically 0.4 A. All right. Now, by what percent should its denominator be decreased? So let me assume that it has to be decreased by X percent. So X percent of B is X over 100 times B, right? Okay, so A needs to be increased by this amount. So A becomes A plus 0.4 A. Now the B needs to be decreased. So B needs to be decreased. So minus X over 100 B, right? So this is the new fraction, and what is given to us is that the new fraction is double the original fraction. So this is the new fraction. This is double. There's 2 times the original fraction a over b, right? All right. Now, if I use the distributive property, this becomes a, the numerator becomes a times 1 plus 0.4 divided by, this is b times 1 minus x over 100, right? Okay, so this has to be 2 times a over b, right? I can cancel out a with a, b with b. All right, so I'm left with, this is basically 1.4, right? 1.4 equal to, I'll take this to the other side, 2 times 1 minus x by 100, 1 minus x by 100. So let me open the bracket. So this is 2 minus 2x by 100, right? I bring this to this side. So this is 2x over 100 is equal to 2. I'll take the 1.4 to the other side, minus 1.4. So 2 minus 1.4 is 0.6. So 2x by 100 is 0.6. This tells me, I take 100 to that side. So 2x, 0.6 times 100 is 60. 2x is 60. If I divide both sides by 2, this is 30. This tells me x is equal to 30, right? And that is what I am looking for, right? I'm assuming that it decreased by x percentage and x is 30. Then again, C is the correct choice. We get the same answer. A triangular pyramid is built with 20 cannonballs, as shown here. Each cannonball is leveled with one of A, B, C, D, or E. There are 4 cannonballs with each type of level. All right, so there are 5 levels, and each type has 4. So 5 times 4 is 20 cannonballs. The picture shows the levels on the cannonballs on 3 of the faces of the pyramid. So pyramid has 4 faces, right? 1, 2, 3, and 4. What is the level on the hidden cannonball in the middle of the 4th face? Okay, in the middle of the 4th face. All right. So for 3D problems like this, sometimes it is difficult to visualize. So, there are 2 techniques oftentimes I try to make use of. One is try to find a reference. We use that in one of the earlier problems. And the second technique sometimes I try to use is try to represent the 3D in 2D, right? Then it becomes much easier to visualize. All right. So we will try to use that technique here. Now, these are the 3 faces that are shown, right? So just for convenience, we can assume that this is one of the face, this is the other face, and there is the other face we are seeing, and the bottom face is the one that is not shown here. All right. Now notice that whichever balls are on the edge, like for example this ball, I will see that in this view as well as this view, right? So for example, the A that I see here and here, they may not be the different balls, right? It may be the same ball, right? Okay, but the ball that is on the top, this one, I will see that from all 3 views. I'll see it from like this, I'll see it from like this, I'll see it also from that view. Now, which ball is that? Now, I can see that D appears 3 times. There is no other letter that appears 3 times at the tip. A appears 2 times, but not 3 times, right? So this must be D. That must be D, right? But then there is another question, right? This is a D. I see that there are two D's at the corners here. There is a D here, there is a D here. Similarly, there is a D here, there is a D here, right? Here there is only one D on the top, so I know that, I'm looking at the face like this, and this is D on the top. But here, how do I know which D is this? Is this one or this one, right? Now, we can try matching the layers on the bottom, and then that is the process we are going to follow. And if we see there is a discrepancy, then we know that that is not the correct D we are looking at, right? So let's keep that in mind. Now what I'm going to do is draw the different layers. Let me call this top layer 1, this is layer 2, this is layer 3, this is layer 4. So I'm going to draw the different layers one at a time, right? Now if I draw it like that, I know that each ball is different, right? Let me show what I mean. Let's call this is layer 1. I know that D has to be on the top, or let me first draw the balls and then I'll level them, right? And layer 2 will be like this. There will be 3 balls on layer 2. Layer 3 will have like this. Layer 4 will be like this. All right. So these are the 4 layers, and we can count. There will be 20 balls. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 balls. And if I draw the layers like that, I know that none of the ball is repeated here, right? Now I have to level them, which ball is which. Okay, so I know that D is on the top layer, so this must be D. Okay, now let's look at the second layer. Let's assume that the 4 faces that the 3 faces that we see are properly oriented, like this is the top instead of this being the top, for example, right? So this layer is taken. This layer, let's try to level the balls and then see if we can do that. CA, so I can start from any corner. Let's say CA, and then I need a BC. So this can be B, and then this is C, and then AB. So it lines up. Then this layer is done. Let's try the third layer, BED. I can start from any corner, BED, EAB. So I end up with B. So I'll start with here, E, A, and then B, and then DEC. Yes, DCE. All right, so they aligned up nicely, but let's check the fourth layer too. DECA. So this layer is done. Third layer, DECA, DECA, and then CBAD. This can be C, B, A, and D. AEBC, A, E, B, and C is already there. Now we see that they are aligned perfectly, so we know that we are looking at the layer. So this is the top layer. This is the top. This is the top. This is the top. As opposed to, let's say, if we're not sure if this is the top D or this is the top D, right? They align perfectly, so we are sure that this is the top D that we are seeing there. All right. Now, as we can see, now we know that each ball appears only once in this view, right? But here it is not guaranteed. As we discussed before, if whatever this ball is, I will see that from 2 views, right? So it's not guaranteed that each ball is unique. but it is guaranteed here. Now simply I can try to count it up. How many A's are there? Let's start counting A. So I see, okay, one more thing, right? Then as you can see, there is one ball here that we don't know, right? And that is what we want to find out. What level goes for this ball? Okay, now let's try to start counting. How many A's do I see? There's 1, 2, 3, 4. So I already see 4 A's. Okay. How many B's do I see? 1, 2, 3, 4. Okay. So I do see 4 B's. Okay. How many C's do I see? 1, 2, 3, and 4. So I see 4 C's. How many D's do I see? I see 1, 2, 3. Okay, I see only 3 D's. Okay, so looks like that is the correct choice. But let's double check E. You see 1, 2, 3, 4. So I do see 4 E's. So there are only 3 D's in the view, right? So the one that is hiding, that must be a D. So that, there are a total of 4 D's, because there has to be 4 D's, right? And this was missing. So that's how I know that that has to be a D. D is the correct choice. Another thought came to mind about this problem. We can actually solve it using these 3 views, but we have to use some logic. Okay. So we are able to see 3 of the 4 faces, right? So let's assume that is this face, and this face, and the bottom face is the one that is hidden. Then we also discussed in the last approach, this ball we will be able to see in all 3 faces, right? And the D is the only one that appears in all 3 faces, right? Nothing else. A appears twice, C appears twice, but they don't appear 3 times. D is the only one that appears 3 times. Then this ball must be D. Then we had another questions. How do we know that this D is this one or this one, right? And we discussed how we can take a look at the next layer and make sure that it lines up properly and you can figure out. And we also discussed that in the last episode, so I am not going to go into the detail about that. But we figured out that the D that we see on the top is in fact this one, and this one, right? So they are aligned properly. So this is the top, the bottom to top, bottom to top, bottom to top. Okay. All right. Now, this is the thing. This D I see in all 3 views, right? So let me count only one and hide the others. For example, this I see in this face. So I have already seen this here, so I'm going to hide this here. Okay. Similarly, I'm going to hide this also from here, because I have already seen it in this face. Similarly, let's go to the next layer. So in this layer, C, A, now this C, I will see it from 2 faces, right? So there will be at least another duplicate. So this C must be this C. So I'm going to hide this one here. This A, I'll see it from 2 faces again. So if I see another A, this is duplicate. So I'm going to hide that. Similarly, B, I will see from 2 faces. So I'll keep this one, I'll hide this one. All right. Next, go to the next layer. This B, I'll see it from 2 faces. So I'll keep this and then I'll hide this B. Okay. Then let me take a look at the other one that is on the edge. This D here, I see that here. So I'm going to hide that here. E, I see it here. Then I'm going to hide that from here. Again, the balls on the edge, I'll see them from two faces, right? So I'm just hiding one of those. Let's go to the last layer next. So D, I see it here, then I'm going to hide that here. A, I see it here, then I'm going to hide that here. No, I cannot hide that here, right? This A that I see, that has to be on the edge. So this A must be this A, so I can hide that, right? Now C, I see it here, then I can hide that here. All right? All right. So at this point, I see all the balls only one time. Okay, now let's count it up. How many A's are there? There's 1, 2, 3, 4. So I see 4 A's. How many B's? 1, 2, 3, 4. 4 B's. How many C's? 1, 2, 3, 4. I see 4 C. How many D's? 1, 2, 3. I see only 3. So again, we arrive at the same answer, but let's double check E. You see 1, 2, 3, 4. I see 4 E's, right? So there are only 3 D's in the view. So the ball that is hiding on the bottom layer that we are not able to see through the edge must be a D, right? Then again, D is the correct choice. The 6-digit number is multiplied by 3. The result is a 6-digit number, this. What is the sum of the digits of this number? All right, let me write it down. 2A, B, C, D, and E. And I multiply this by 3. And I end up with A, B, C, D, E, 2. All right, so one thing to note here is I'm multiplying 3 with E and I'm ending up with 2 at the unit place. So it will be helpful to write down the multiplication table of 3. Let me do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'll put the 0 here. So 3 times 0 is 0, 3, 6, 9, 12, 15, 18, 21, 24, 27. All right, so this is a multiplication table for 3. 3 times 0 is 0, 3 times 3 is 9, so on and so forth. All right, so I'm multiplying 3 with E and I get 2 at the unit place. The only times I get 2 at the unit place is if I multiply 3 with 4. Nowhere else I get 2 at the unit place. Then E must be 4, right? Okay, if E is 4, so this E is also 4, right? They are the same letters. Okay, now then I have to multiply 3 with D. Again, if I multiply with 4, the carryover is 1, right? So I have to remember that I get 2 at the unit place and then I get 1 as the carryover. Now I have to multiply 3 with D. So whatever I get, I add 1 to that and then I end up with 4, right? So whatever I multiply, I must end up with a 3, so that when I add 1, I end up with a 4. The only times that I end up with a 3 is 1, right? So D must be 1 then, right? So then I multiply 3 times 1 is 3 plus 1, I end up with 4. Then D is 1. All right. Similarly, we can continue. I'm multiplying, and there is no carryover now. I'm multiplying 3 with C, and I end up with 1. So when do I end up with 1? If I multiply with 7, right? So then C must be 7. So that 3 times 7 is 21. 1 here, carry over 2, right? And then this C also is then 7. Similarly, I am multiplying 3 with B, and then if I add 2, I end up with 7. Then when I multiply 3 with B, I must end up with 5, right? So that's when I add 2, I end up with 7. And when do I end up with 5? It's a 5, right? So B must be 5 then. So 3 times 5 is 15, plus 2 is 17, 7, and 1 is carryover, right? So again, B is 5. Okay, so when I multiply 3 with A and then add 1, I end up with 5. So I must end up with 4 when I multiply 3 with A. When do I end up with a 4? That is 8, right? So A must be 8 then, right? So this must be 8 also, right? Then 3 times 8 is 24, plus 1 is 25. I end up with a 5 here, and then carry over is 2. 3 times 2 is 6, plus 2 is 8. All right, so it matches up. All right, now what is the sum of the digits of this number? So the digits are then 2, 8, 5, 7, 1, and 4. We can simply add it up. So 2 plus 8 plus 5 plus 7, 2, 8, 5, 7, 1, 4. So this is 10, 15, this is 22, and this is 5. So this is total 27. Then B is the correct choice. A box contains only green, red, blue, and yellow counters. There is always at least one green counter among any 27 counters chosen from the box. Alright, some conditions are given. We will go through that one by one. And the question is, what is the largest number of counters that could be in the box? So let me write down the different colors: green, red, blue, and yellow. And there is always at least one green counter amongst any 27 counters. So if I choose 27 counters, I'm guaranteed to have one green. So I'll just note that number on the top. There is at least one red counter amongst any 25 counters chosen. So I'll note down that 25 here. At least one blue amongst any 22 counters. I'll note down that number here. And there is at least one yellow amongst any 17 counters. Okay, so I'm just noting down those numbers here. If I choose 27 counters, I'm guaranteed to have at least one green. If I choose 25 counters, I'm guaranteed to have at least one red. So I have just noted those numbers here. All right, so let's try to think about this. So let me write down the colors one more time: green, red, blue, and yellow. Okay, now if I choose 27 and is guaranteed that I have one green, what is the maximum number of red plus blue plus white there can be? 26. One less than that, right? So that if I choose total of 27 counters, even if I choose all these, which will have 26, then I'm guaranteed to have one green, right? This point is very important to understand. Then everything else is easier if we can understand this point, right? Similarly, we can do for the other colors, right? So R plus B plus Y, the maximum there can be is 26. So let me write that down: R plus B plus Y. The maximum that can be there is 26, and we want to find the largest number of counters, right? Again, try to think about it one more time. Let's say I have 27 or more of R plus B plus Y, right? If I have 27 or more, I could, and if I choose 27 counters, just R plus B plus Y could be those 27. I'm not guaranteed to have one green, right? So R plus B plus Y has to be one less than this number that I have noted here, right? Similarly, for red, G plus B plus Y, G plus B plus y has to be 1 less than 25, that is 24, right? Similarly for b, g plus r plus y, g plus r plus y has to be 1 less than 22, which is 21. Similarly for y, g plus r plus b, g plus r plus b has to be 1 less than 17, which is 16, right? All right. And I need to find largest number of counters, so we need to find r, g plus r plus b plus y. We need to find the value of that. Okay. Now, if you stare at this equation, right, if I add everything up together, I can see that there's 1, 2, 3 of red, there is 3 of green, 1, 2, and 3 of blue, and 3 yellow. So every color appears 3 times. So that is 3 times g plus r plus b plus y, g plus r plus b plus y, that is equal to 26 plus 24, 26 plus 24 plus 21 plus 16, right? All right. So basically, I want to divide the whole thing by 3, right? Okay. So the answer, so this will be 26 plus 24 plus 21 plus 16 by 3. And I know that this number will be divisible by 3, right? Because I'll have an integer number of counters. So what I can do is first divide this with 3. So this will be 8. This will be 7. I'm dividing 3 with that. So 26 is not individually divisible by 3. So I can add up 26 with 16. So that is going to be 42. And then I can divide by 3. So this will be 14, right? So if I add it up, 8 plus 7 is 15 plus 14. So this is going to be 29, right? Then the correct answer is B. 2021 color kangaroos are arranged in a row and are numbered from 1 to 2021. Each kangaroo is colored either red, gray, or blue. Amongst any 3 consecutive kangaroos, there are always kangaroos of all 3 colors. All right. Bruce guesses the colors of the 5 kangaroos. These are his guesses. Kangaroo 2 is gray. All right. Here are some of the guesses. Only one of his guesses is wrong. What is the number of the kangaroo whose color he guessed incorrectly? All right. Let me first write down few numbers. 1, 2, 3, 4, 5, 6, 7, 8. All the way there are 20, 21 kangaroos. So there are red, green, and blue, and among any 3 consecutive kangaroos, there are always kangaroos of all 3 colors. We don't know how they are arranged, whether are red, green, blue, or red, blue, gray, or we don't know. So let's call them, whatever color it is, color 1, color 2, color 3. Because among any 3 consecutive kangaroos, there are always kangaroos of all 3 colors. So even if I take first 3, I should have all 3 colors, right? Now, if I take the next 3, I should still have all 3 colors. But I have C2, C3, so this must be C1, right? Then if I take next 3, again I should have all 3 colors. C3 is there, C1 is there, this must be C2, right? And you can see the pattern. Now if I take the next 3, C1 is there, C2 is there, this must be C3, right? So as you can see, whatever C1, C2, and C3 are, they must follow this pattern, like C1, C2, C3, C1, C2, C3, so on and so forth, right? All right. So once you have figured this out, now let's try to look at the different kangaroo numbers. So he is guessing, so this is kangaroo number and this is color. Okay, kangaroo 2 is gray, so 2 is, I'll denote G for gray. 20 is blue, 20 is blue. 202 is red, 202 is red. 1002 is blue, 1002 is blue. And 2021 is gray. Okay, so one of this is not going to match this pattern and we have to find that out. Let's assume, let me just mark it like this so that we don't get confused. Let's assume that 2 is gray, right? And then we have another gray for 2021. So do they match this pattern, right? If 2 is gray, is 2021 going to be gray? So the way we can find out is, from wherever we end, right? Every third from that has to be the same color. For example, let's say if I end here, every third, 1, 2, 3 has to be the same color. If I end here, every third, 1, 2, 3 has to be the same color, right? So if I end at 2, so 20, 21 minus, if I subtract 2, that's where I end. That number has to be divisible by 3, right? Then it will be in that pattern. So this is going to be 2019. Is that divisible by 3? So if we add the digits, if that sum is divisible by 3, then that number will be divisible by 3, right? So here 9 plus 1 is 10 plus 2 is 12. 12 is divisible by 3. So yes, they do follow that pattern. Okay. Now if 20 is blue, he also says that 1002 is blue. So let's check these two numbers now. So 1002, if I subtract 20, 982, right? Now this number has to be divisible by 3, is it? Now 8 plus 2 is 10 plus 9 is 19. 19 is not divisible by 3, right? So one of this has to be incorrect, right? And which is incorrect? Okay, now let me check these two. What if, let's say I start with gray, then what will be the 20th? Let's say 20, let's check if that should be a gray or something else. So if I subtract 2 from 20, that is 18, and 18 is divisible by 3, right? Then this 20 has to be a gray. It cannot be a blue, right? Because that follows that pattern. So then this is the one he guessed incorrectly. Then B is the correct choice. A 3 by 4 by 5 cuboid consists of 60 identical small cubes. A termite eats its way along the diagonal from P to Q. The diagonal does not intersect the edges of any small cube inside the cuboid. How many of the small cubes does it pass through on its journey? All right, so the termite is going to eat from P to Q on a straight line, and that line does not intersect the edges. So it, from one layer to other, it goes through the face, not through the edge, right? So this problem is actually a bit difficult to visualize because it's a 3D problem and also a bit difficult to explain. So I'll do my best. Let me draw a line from here to here, because if I look at the path from this face, from this view, right? So let me try to draw that line. Okay. So this is what it will look like. It will be a straight line, but it will look like this if I'm looking from this face, right? Now, note that any point that we see in this figure, right, in 3D, that's actually an edge. But any line that we see on 3D, that's actually a face of the cube, right? Let's keep that in mind. So I have drawn it such that it doesn't pass through any of the points, right? Because actually we can also prove that given this dimension, right, the line will not pass through any of those points that will convert to an edge in the 3D, but we can just assume, and it is given to us, we can just assume it. So again, this is the view looking straight through this face. Now in this view, how many cubes it is passing through? This is 1, 2, 3, 4, 5, 6, 7, 8. All right. So it is passing through the 8 cubes. But in reality, it's going to from P to Q or Q to P, doesn't matter. It's a straight line. So in reality, right, it's not going from this to this corner. It's going from this to this corner here, right? Now, this is the key. While it is going from here to here, it has to go from this layer to the next layer, right? Again, from that layer, it has to go to the next layer. But from this layer to the next layer, it is not going to cross through the edge that is given to us. So it is going to pass through a face of the cube, right? So from this view, like third way, if this length is the length that I have drawn is whatever the length is, 1/3 of that somewhere here, right? It is actually going to cross to the next layer. It is going to cross to this layer, the second layer, right? So what I see here is one passing through one cube, that will be an additional cube from this layer, right? So that is plus another one. I see only one here, but it is passing through the face, so it is actually touching the cube on the second layer. Similarly, on 2/3 of the way, somewhere here, what I see as one cube from this view is actually going to pass to the third layer, right? It's going to pass to the third layer. So what I see as one cube here, that will be another cube from that layer, right? So that is plus one more. And this path that we see, this will be on the second layer, and this path is going to be on the third layer, right? Then I'm done. Then I arrived at P. So this will be total of 8 plus 1 is 9 plus 1 is 10, right? It is going to pass through 10 cubes. Again, this problem is a bit difficult to visualize. So actually I have made a drawing. So let me show the drawing. So here in this slide, I have drawn a big version of the same cube. And actually I have already drawn the straight lines. So this line is if I'm looking straight through this face. Let's say there are two persons, right? Me and somebody else, you. So I'm standing looking through this face. You are looking straight through this face. So when the termite is going from Q to P, I will see it go like this to here. But you will see it going like from this face, you will see it going from here to here. All right. Now, again, it is already given that it doesn't cross through an edge, but here I can clearly see it, right? It's going through the line that converts to a surface in 3D. So here also we can see 1, 2, 3, 4, 5, 6, 7, 8. It's going through 8. But when you see the termite, right, going from here to here, at this point, right, you can clearly see that it is going from this layer to this layer, right? This is, let's say, layer 1, this is layer 2, this is layer 3. You will see that termite is going from the first layer to the second layer. But if I take a look from my view, I will not see that. I will see as if the termite is still in the same cube. But that is not true. In 3D, you can clearly see that actually it is touching another cube, right? Similarly, at this point, you can clearly see that the termite is going from the second layer to the third layer. But if I look at my view, it is still in the same cube, right? So think about it. From here to here, right? The termite is going to be on the second layer. From here to here, the termite is going to be on the third layer, right? So what I see as 8 here, like I have marked it 1, 2, 3, 4, 5, 6, 7, 8. There is actually one more right here. So this is, instead of one, there are 2 cubes here, right? You can see that clearly here, but from my view, I cannot see it, right? Similarly, what I see as 1 cube here is actually 2 cubes, and you can clearly see that here, right? So it's actually these 8 that I have marked plus the 2 extra that you see. So 8 plus 2 is 10. Again, it's the same answer, of course, but I wanted to give you a larger view of the path. Hopefully this makes it a little bit more clear. Think about it. This is a 3D problem. It takes a little bit of imagination. So please give it some time to think about it. So this problem is definitely a little bit tricky. So I was trying to think if there was another way, another simpler way I could explain. So here I have a couple of examples in 2D. So we'll try to first understand this and then extend it to 3D, right? So first I have a square, bigger square divided into smaller square, and the dimension is same, 4 by 4. And here I have a rectangle, right? The dimensions are different, 4 by 3, and that is divided into smaller squares. Okay, so in this case, if I draw a line from here to here, it is going to always pass through this corner, right? So in that case, how many squares I see in total? This is 1, this is 1, this is 1, this is 1, and that is it. 1 from every layer, right? But when I see 1 from every layer this way, that also cover these layers. So I see a total of 4 in this case. 4 is same as whatever the dimension, one of the dimension, right? The dimensions are the same, so whatever is one of the dimension, that's what it is going to be. However, when it is a rectangle divided into smaller squares, right, these dimensions are not the same. So in this case, I'm going to see one from every layer in this direction. That is this one, this one, this one, and this one. So I'm still seeing 1 from every layer. So that is, I'm seeing 4, right? I'm seeing 4. And then since it is not going to cross through the corner, it is going to cross through one of the edge. I'm also going to see one each from these layers, like this one, and in this case, this one, right? So in this direction, right, first layer I had already seen. So I'm seeing 2 more, which is less than, 1 less than this dimension. So 4 plus 3 minus 1, this gives 4 plus 3 is 7, minus 1 is 6, right? So in this case, I will meet total of 6 squares, 1, 2, 3, 4, 5, 6. All right. Now in this case, all the 3 dimensions are different, right? And also we are told that, the diagonal doesn't intersect the edges. We can see that in 2D, but in 3D it is already given to us. So what is going to happen in this case is, this is 5, this is 4, this is 3, these are the dimensions, right? So the first one of in one dimension, I'm going to see everything, and the other dimension, I'm going to see 1 less, just like here. And in the third dimension, same story, 3 minus 1, right? So whatever the dimensions are in the other 2 directions, minus 1 each. So this will lead to 5 plus 4 is 9, plus 3 is 12, minus 2 is 10. So we are going to arrive at the same answer, of course, but I thought this gives a different perspective. Maybe a bit more theoretical, bit more abstract. If you understood the previous approach, great. If you also understood this one, more power to you. In a town, there are 28 knights who always tell the truth and 2000 knaves who always lie. A wizard divided 2020 of these 2021 people into 10 pairs. Every person in a pair described the other person as either a knight or a knave. As a result, 2000 people were called knights and 20 people were called knaves. How many pairs of two knaves were there? All right, let's say there are X pairs of knight and knight. There are Y pairs of knave and knave. And then let me call, B pairs of knight and knave. B for both knight and knave. All right. We know that knights always tell the truth. Knave always lie, right? So if I ask this pair, what is the other person? The knight is always going to tell truth. So it's going to say knight because the other person is a knight. And he is also going to tell the truth and say knight because the other person is a knight. So from each pair, I get two knights. Right? All right. How about here? Knave always tells a lie. So he's going to lie about the other person. So he's going to say he's a knight. Similarly, this knave is going to lie about the other person and say he was also a knight. So from a pair where both are knave, I get two knights. How about this pair where there are both knight and knave? Knight is going to tell the truth, so he's going to say that the other person is knave, but knave is going to lie and say even though the other person is knight, he is going to say the other person is a knave. So here I get two knaves. Okay, so from each pair of knight and knight, I hear two knights. From each pair of knave and knave, I hear two knights. And from each pair where one is a knight and the other is a knave, I hear two knaves. All right, but we are told that 20 people were called knaves, right? Now this is the only combination where there is a knight and knave. We hear two knaves from each pair, right? But we are hearing 20 knaves, right? 20 knaves. So then there must be 10 pairs. 10 pairs. So the B must be 10, right? Because from each pair I hear two knaves. From 10 pairs I will hear 20 knaves, right? All right. If we have 10 pairs of knight and knave, think about it. We have 21 knights, right? So 10 are already paired up. How many remaining? 21 minus 10. So 11 are remaining. But they are paired as knight and knight. There is no more knight and knave pair left. 10 is all we have based on how many knaves we are hearing, right? So in this case, this 11 will be paired in a group of 5 pairs. 5 pairs, and then will be one extra remaining, right? 5 pairs, 5 into 2 plus 1, right? So there will be a group of 5 pairs of knight and knight, and then one extra remaining that is not going to be paired with anyone, right? Because if it was paired with a knave, then I would have that here, right? Okay, so we know that B is 10 and knight that is 5, so X is 5. Okay, now how many total pairs we have? We have 10 total pairs, 10, right? Minus 10 is 1000. So 1000 is X plus Y, right? Because I have already taken out the 10 pairs of knight and knave. Okay, and I have already calculated there are 5 pairs of knight and knight, so minus 5. So this is going to be 995, right? Then we must have 995 pairs of knaves, right? Then D is the correct choice. In a tournament, each of the 6 teams plays one match against every other team. In each round of matches, 3 take place simultaneously. A TV station has already decided which match it will broadcast for each round, as shown in the diagram here. In which round will team D play against F? So DF. All right. So what we can do is first list out all possible matches. So let me do that. AB, AC, AD, AE, AF, then BC, BD, BE, BF, then CD, CE, CF, DE, DF, and then EF. So these are all possible matches, right? All right. Now, okay, we want to find out in which round will team D play against team F. So these are the 5 rounds. So this is round 1, 2, 3, 4, 5, and we already know some pairs. So let's cross that out. AB, we already know. CD, we already know. AE, we already know. EF, we already know. AC, we already know. All right, so we already know which round they play. Now let's try to find a pair and see where it can go. Let's say AD. Okay, can AD go here? No, A is already playing, D is already playing, A is already playing, A is already playing here. So AD, so this is the only possible place AD can play. Okay, so AD is already placed. How about AF? A is already playing here. AF seems like possible here. A is already playing here, A is already playing here. So AF must play here. In fact, once we know, both the 2 matches, we can already figure out 3, because in each round all the teams must play, right? So if CD is playing, AF is playing, then A, B is still there, C, D, E, and then F. So BE must play here, right? BE must play here. How about here? A is already playing, B is still there, C is still there, D, E, F. Then BC must play there. Must play there. All right. Let's see where BD will play. B is already playing here. This is a possibility. This is a possibility. So there are 2 choices for BD. So let's forget that for a moment. Our BF. B is already playing here. This is a possibility. This is a possibility. So let's forget about BF. Let's see CE. E is already playing here. C is already playing here. That means CE must be here. Okay. We know 2 games. We can figure out the other one now. A is playing, B is playing, C is playing. So D, and then E, then F, right? So all the teams are playing here, right? So DF must be playing here. So DF is crossed out. And in fact, that's what we want. Where does DF play? So DF must play in round 1. That's the correct choice. The diagram shows a quadrilateral divided into 4 smaller quadrilaterals with common vertex K. The other level points divide the sides of the large quadrilateral into 3 equal parts. The numbers indicate the areas of the corresponding small quadrilaterals. What is the area of the shaded quadrilateral? Alright, so what is the area of this shaded quadrilateral? So somehow the area of this quadrilateral should be related to the area of the other quadrilaterals. Now the question is how? Just by looking at it, it's not very obvious, but we have one piece of information that we can use, that is this length we know is equal to this length is this length, right? Because that's what it is given to us, into 3 equal parts. So these points divide this side into 3 equal parts. All right. So it should probably strike to you that if they have the same base, somehow if we can make triangles with them with the same height, they will have equal area, right? What do I mean? So let's say so this length is same as this length is same as that. So if I have a triangle, I have triangles like this. So I have this 3 triangle. This length is same as this length is same as this length, and whatever the height, right? So area of the triangle is half base times height. Base is the same for all 3 triangles. Height is also the same. So these 3 areas must be the same, right? So we will try to make use of that here. So what I want to do is, having these as the base, let's try to find a common point, and naturally the K is the common point, right? That's why everything is joined. So what I will do is I'm going to draw it like this. Similarly, I'll do it for the other sides. All right, I'll join this, this, and this. Then I will join this and this. And I'm going to join this and this. All right. Now let me level those areas. Let me call these as A. This has to be the same area A. This has to be the same area A, right? Again, so these are 3 triangles. The base is the same length and height is the same. So they must have the same area. Next, let me call this area B, B, B. Again, same region. These 3 areas must be the same. Similarly, these 3 areas, let me call C, C and C, they must be the same. Same way, these 3 areas, D, 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 they must be the same. All right, now what do I see? A plus B plus B must be 18, because that is the area of the quadrilateral given to us. That is 2A plus 2B, that is 2A plus B, that is 18, right? That is given to us, area of that quadrilateral, which is divided into these triangles. Similarly, B plus C, B plus C, B plus C, that is this quadrilateral, that is 8. Area is 8. Same way, C plus D plus D, that is 2C plus D, 2C plus 2D, that is given to us as 10. Okay, and we want to find out what is the area of this shaded quadrilateral, which is A plus D, right? So we want to find out what is A plus D. We want to find that out. All right, now I want to find out A plus D, right? So here is A, here is D. So looking at this equation, let me number those 1, 2, and 3. Just by looking at these equations, can I add equation 1 with equation 3? So equation 1 plus equation 3. That will give me 2 times A, B, C, D, right? 2 times A plus B plus C plus D, right? And that should be equal to 18 plus 10, that is 28, right? Now divide both sides by 2, so this is 14. Now C, B plus C, right? B plus C is given to us, that is 8, right? So B plus C is 8. Now can I subtract 8 from both sides? Yes. So this will become 14 minus 8 is 6, right? Now what am I left with? A and D, right? So that tells me A plus D is equal to 6, right? And in fact that is what I want, A plus D, right? A plus D is the area of this shaded quadrilateral, and that must be 6. So C is the correct choice.